Whew. All right, let's try it. Let's try this way. So now we're here. Okay, hopefully you can hear me and I'm not double speaking. Okay, I gotta check my voice, check my mixer. Zero, okay, 0, 0. Okay, so what we're gonna do is we're gonna count on the abacus. What we're gonna do is we're gonna count on the abacus. So we have 1, 2, 3, 4. This is 4 on the abacus. I kind of like this. I'm testing something new. Okay, so 4. All the beads that are touching this horizontal bar is considered 4. What does that mean? Well, because these are touching the horizontal bar, this is the horizontal bar. This horizontal bar counts, it tracks the beads. So this is 4. Well, what happens to 5? This is 5. The top bead will always be 5. And because the top bead is 5, then this is now being counted. This is what we call an abacus. This abacus is a math tool. This math tool will help us first how to learn. The first thing we need to do is learn to read the abacus, and then after we read the abacus, we're going to learn how to add, subtract, multiply, and divide. Good evening, everybody. Welcome, welcome, welcome. Welcome to Midnight Math. Welcome to Midnight Math. So we're going to be mathing in the middle of the night. So we have 5, 6, 7, 8, 9. If you notice, we have 9 on the abacus. That means that when all these beads, oh my gosh, all these beads are being squished together on the horizontal bar. This horizontal bar is what counts. So right here, if you notice these columns, and we talk about columns, these columns are not touching. None of these beads on these columns are touching the horizontal bar, so these beads are not being counted. Hello, everybody. Hello, Kat and Chanterelle and Junior Capisto. So, when we read the abacus, we are going to be doing 1, 2, 3, 4. After 4, hey, Trek and Jen, after 4, we have 5. 5 is going to be the top bead and always the top bead no matter what. Forever and ever and ever. Will always be the top bead. So we have 5, 6, 7, 8, 9. Well, then you might be wondering, well, what happened to 10? Well, 10 is 1 and 0, just as we have it here. 1 and 0. So if I was to write it and it says 1 and 0, this is 10. Because we have 10, we can show that on our abacus. We have 10s and 1s. Welcome, welcome, welcome. Alexa, tell me a joke. Ooh, ha ha ha. That's a good one. That's a good one. Each column is a place value. So if you can see, each of these columns is a place value. Thank you so much for the likes. So when we're reading it, we have our ones, our tens, our hundreds, our thousands, and our 10,000. So the first thing we're going to do is we're going to understand how to read the abacus. When we learn how to read the abacus, then we can do adding, subtraction, multiplication, and division. So if anybody has any questions, let me know. I know this is still early, and I'm just talking about how to read the abacus. If we understand how to read the abacus, that's really good. So we're going to count 1, 2, 3, 4. All the bottom beads has a value of 4. The top bead will always have a value of 5. Does anybody have any questions? Anybody have any questions? Because I don't want to be the only one in the room. So we have 5, 6, 7, 8, 9. After 9, we have 10. Notice we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Because we have that, we can have our, what do you call it, place value. So with our place value, we can continue to count. So we have 12, 11, this is 11, this is 12, 13, 14, and then this is 15. Hopefully you guys can hear me. This is 15. Are all the place values the same on the abacus? Yes, Kat, they are. It all just depends, though, on your indicator. So if my indicator is here, then this will be the ones. If I choose to use this as my ones, then this will be my indicator, if that makes sense. So this would still be ones. So ones and tens, just as we write. So it doesn't matter if we write, a 10 over here or a 10 over here. What does that mean? So a 10 is a 10 is a 10. Okay, good. Then I don't need to explain it. Good. I'm so happy that you got it. Makes sense, right? So the other thing is, why are there so many dots? Well, it's nice to be able to have these indicators to help us section the group our group our digits. What does that mean? Well, you know how we have the thousands and then we have a comma and then 438? Well, that comma, and I wrote it really horrible, that comma, like this, is what indicates the dot. Does that make sense? So we have 1,438. Whoa, that's not it. There we go. 1,438. Does that make sense? Yeah? Good. Thank you, Kat, so much for the comment, because now I know I'm not alone. All right, all right. So what's going to happen is we're going to continue to count and read the abacus. As we see, all the lower beads has a value of 1. All the lower beads. And then this top value is going to be always going to be 5, no matter what. So when we count it, we have 5, 6, 7, 8. If you notice, we can actually start talking about decomposing. And decomposing means that we can actually take apart the number. So if we do 8, 5 plus 3 is 8. If I want to do 9, it's 5 plus 4 is 9. Are we all right? We're okay? Thank you for so much joining. Thank you for joining. Let me know if you have any questions. It seems like you're the only one in the room. So if you have any questions, hey, Harrison. Okay, we're going to continue on and we're going to change out my number. Okay, but before I do that, I need to, there we go. All right, I need to erase my number. There we go. Because I don't want to confuse anybody. Okay, so what are we going to do? We are going to count 1, 2, 3, 4. This is 4 on the abacus. Anytime this is the horizontal bar, this horizontal bar is tracking. Oh, the base! I'm about to head out to bed, but I got an abacus. Whoa, that's cool! How many columns did you get? How many columns did you get? That's fantastic. That's awesome. I'm so happy. All right. I have a BS in degree math and never knew how this worked. Oh, really? In my opinion, I can't believe I'm learning them from TikTok. Yeah! Oh, good. I'm so happy you're happy about it. Because, Kat, it'd be upsetting if you were like, you know what? Screw this. This is BS. Yeah. You know, it's really interesting. So I'm not sure what you want to do with the, I don't know what you want to do with it, but I actually have 3 boys and they all gone through the Abacus curriculum. And it's interesting because we talk about the concrete, and after the concrete, then we do pictures. And then after the pictures, right? So we have the concrete, and then afterwards we have the pictures. And then after doing the pictures, we have the abstract. So it's really quite interesting. I find it interesting, and I really do believe in it. The reason why is because I think it really helps to see how the numbers work. Let me know, Kat, if you have any questions, because so far, other than Ode to Base, you're the only one that's commenting. So I will talk to you and make sure that you're okay. I'm just rearranging my stuff, actually. Sorry. I didn't realize how stuff was out. Okay, so the first thing we're going to do is we're going to understand how to read the abacus. And are we okay? Do you know how to read the abacus? It makes sense, right? It's like super easy. Simple to use. Do you sell this? I do. I sell the abacus on my website. If you want a PDF version of this, I also sell this on my website. If you want a book version, I have a book version and I sell that on Amazon. And you can find my name. You can find my name. This one was geared towards preschoolers. So what I wanted to do was I wanted to get them to understand how to read the abacus and read the numbers and understand the pictures and how to how to trace the numbers and so forth. And there's some activities, right, to get them a little bit more engaged. So this one is color pixel art. And what it was is, they find the number, they get to choose whatever color they want, because I wanted them to choose, because sometimes the kids, they want to know what they want. They want to choose their own color. So I got them to figure out the colors, and then they have to figure out what this number is. So this is a picture of the abacus, and ideally you would have the abacus and then the picture of the abacus. And then after they have that, then they can find the number. So it's about bead recognition and number recognition. And so this one specifically, all my books and all my worksheets are very abacus specific. The reason why, because there's not a lot of abacus specific activities. So I'm trying to abacify the world. That's what I'm trying to do. I'm trying to abacify. So yes, but yeah, this one, I mean, if you want it, I do sell this as a PDF, as a digital download. But if you want a physical book, I do sell it on Amazon, and it's there. And this is also I sell, but you can get a 13 column one from Daiso if you want one for yourself. I would recommend, if you want it for yourself, I would recommend a 13 column one because it's easier to do multiplication and division. That's the only reason why. This one is good for the young kids, but it's also good because, if that makes sense, because the questions are smaller, then it's fine to use this one, and I do like it because it's colorful. I've been teaching for about 20 plus years on the abacus, and so I kind of got bored with the brown. The brown is a very common a common abacus, and so there's other abacus as well. I'm not sure if you know, but this is considered a soroban, and the soroban is a Japanese version of the abacus. There is a Chinese version of an abacus, and this is the Chinese version. It works exactly the same, except there's extra beads, and the beads are a little, and some of the steps are a little redundant. Yeah. So I'm not sure like how far along you are in your degree, in your math degree. And I'm not like, are you planning to go as a researcher in math? That would be really interesting, because what I was trying to figure out is do like how to research abacus, within kids and stuff. But I'm not a researcher, so I that's like above my pay grade. But yeah, I do, yeah. So I really like the abacus. I think it's the greatest thing next to sliced bread and next to Betty White. I hope you know who Betty White is. She was so funny. She was so funny. I loved her in Golden Girls and then all the other things that she's in. So again, what we are doing, the first thing we need to do is we need to understand how to read the abacus. Now we understand how to read the abacus. No, I have a doctorate now, and now, oh, I'm a principal. No math for me, but I love math for fun. Ah, fantastic. Congratulations. Woo, a doctorate and now a principal. Wow. That's pretty cool. My goal, I don't know, I'm hoping to try to I'm trying to popularize abacus because I do believe, yes, see, I can multiply on the abacus. We can do that in a little bit. But the first thing I want to do is understand adding and subtracting, because what multiplication is just fast addition. What a few things that we need to understand is, how do we add on the abacus? And so since it's just you and I, we will do that. All right. We will do that. Okay. Hey, Spider Monkey Mary. Okay, so the first thing we're going to do, and you will notice that we've actually started a little bit about adding, and that was the decomposing the numbers. So if you notice that this was 9, as 9 in the ones column, right? We have the ones, the tens, the hundreds, the thousands, and the 10,000. In the ones column, you'll notice that we can actually decompose. Because we can decompose, we have the 5 and a 4 will make 9. Does that make sense? So when we look at it, we're like, oh, what abacus does is it makes it into manageable chunks. So after 5, the human brain cannot see items after 5. We have to start counting it. So it's interesting how the abacus will assist, how we see and how we read things. So as I look at this, I will always know I can subitize that this is 9. If I look at it, I know this is 5. So when I look at it again, this will be 7. I have 1 bead on top and 2 beads on the bottom. 2 plus 5 is equal to 7. So that was where I was talking about this book towards the end, after we start doing the relationship of the numbers. So we count forwards, we count backwards, we can actually do adding and subtracting. But in school, and I don't, and correct me if I'm wrong, Kat, in school, in the younger grades, we teach the kids to focus on the result. But in abacus, we don't focus on the result. What we focus on is the add-in. Excuse me. We need to focus on the number that we're adding to. So when we have a question, let's say this one, 5 plus 6. 5 plus 1. So if when I clear my abacus, and I'm going to do 5, and I just need to add the 1. The idea is to be able to move this bead. I want to move the 1 bead. Hello, Sorcerer of Shadows. So I want to move the one bead. Because I move the one bead, I know how this is being used. I know what I'm doing. I know how to use the how to add a 1. Because I'm adding a 1, I know that this is 6 because now I counted 5, 6. It's the same thing here. I'm going to add the 1 and then I add 7 because it's 5, 6, 7. So I add 7, right? So my answer is now 8. Again, if I have 8, this is 8, and I want to add 1, my answer is 9. So again, we're focusing on the added. Now my next one is I do 2. That's easy, right? So if I have 5, I'm going to have 5. I add 5 on my abacus, and now I'm going to add 2. All I have to do is add the 2 beads. And then you're like, wait a minute. Well, what happens when we have no more beads, right? Because so abacus provides, it helps guide the children or whoever's doing abacus, guides critical thinking, because now we're going to start working through the framework of abacus. What does that mean? Well, if you notice, we in the abacus world, we don't learn our doubles. So the first thing I can do is, let's say we do 4 and we add another 4. Well, when we add another 4, where is my book? When we add another 4, we teach the children how to make a 5. So that's a great thing, right? The great thing we're going to do right now is we're going to know how to add a 5. To make a 5, we teach the children 4 plus 1 is, oh, there we go. 4 plus 1 is equal to 5. We are teaching this to children. That's not a problem. The issue is not, it's not an issue. The interesting thing about it is, and my camera is really wonky. The interesting about it is, come on. The interesting about it is, we talk about this, not a problem, but that's as far as it goes. And it's kind of, oh, my gosh, now I'm just playing with it. Okay, there we go. Oh my gosh. All right. So what's going to happen is, we know the different ways of adding, how to make a 5. The reason why we want to make a 5 is because we want to utilize the top bead. Remember, the top bead has a value of 5. But if you notice, if I have 4 and I want to add the 5, I don't have any more beads. So the question is how do I utilize the 5? When I utilize the 5, we need to understand how to make a 5. So this is a concept we're teaching the children. 3 plus 2 is equal to 5, and then 2 plus 3 is equal to 5. We know this. But now what we're going to do is we're going to supercharge. Let me see if I can do this right. We're going to supercharge our equation. What does that mean? What we're going to do is we're going to isolate the variable. The question is going to be 4 plus 4, right? That's the question. What we're going to do is we're going to supercharge. We're going to isolate this variable. When we isolate this variable, this means that we're going to move this to the other side. It looks very familiar as algebra, doesn't it? But we're not doing algebra. We're doing like algebra. We kind of want to be algebra, but we're not. It's like algebra is the big brother, big sister, and the abacus is the little brother and the little sister, and they want to make up, they want to be like the big brother. Make sense? So what's going to happen is, when we isolate this variable, we're going to move it to the other side. I'm going to rewrite the equation to be plus the 5 minus the 1. Now, let's replace it back to the 4. Notice we have 4 is equal to plus the 5 minus 1. When we do this, what's going to happen? Because we isolated this variable, we're going to substitute this information to here. What? How are you going to substitute it? Well, if you noticed, I have 4. Now I'm going to add the 5, and I take away the 1. Because that's what I want to do, is I want to add the 4. This is the 4. So what I just did was I substituted plus the 5 and minus the 1. So I added the 5 and I took away the 1. So now my answer is 8. What I just did was not memorize our doubles. What I just did was understand how to fundamentally use our formulas. We're using concepts of plus the 5, plus 1 plus 4 is 5. 4 plus 1 is 5. We're using this concept, and we're going to supercharge it and make it utilize. We're going to utilize and make it versatile. Does that make sense? So what we just did is we made sure that our numbers are not lazy bums. IO? Right? Easy. But see, the thing is people are like, you know what? That you make it sound really complicated. It's like, it sounds complicated now only because the numbers are easy. What happens is, what the difference is, when this, we can actually use this in a scale. So what happens is when we have more numbers, this becomes more critical. We only need to know 4 sets. Ha ha, Io, just blew my mind. I'm not gonna lie. Yeah, I know what NGL is. I'm so old. Wait, what makes it so Wait, that makes so much sense when you explain it so well. Thank you, Sophia. Thank you, Sophia. I take pride in that, actually. I really do. But see, that's the thing. Like, everybody will, not everybody, I take that back. There are some naysayers that are like, you know what? You just made it more complicated. I was like, whoa, okay. You do you. I'm okay. You do you. Right? But what it is because we know the fundamentals, then we can scale it, right? The idea is to be able to understand and to do a deep dive in adding and subtracting. I think in school we underestimate the power of our formulas. We underestimate the power of adding and subtracting. So let's take it one more step. So the upper bead is a value of 5. Yes, Io, it is. You're absolutely right. So when we count, we have 5. When we count, we have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is my horizontal bar. Anytime the beads are touching my horizontal bar, this is now being counted. So when we look at it, we have 5. So we have 4, and then we have 5. 5, 6, 7, 8, 9. Then now we start talking about place values. We have our ones, our tens, our hundreds, our thousands, and our 10,000. That's why I had this little thingy. So I have it where if I wanted to do 10, all I got to do is that. Does that make sense? So I'm trying to line it up to each column is a place value. And it makes it easy. It makes it easy. You know why? Because Abacus will help you keep the... I just lagged. Oh my God. Oh my God. Do I have a yes? I do. I have to go. Okay. Yesy. Yeah. I mean, my bio, I have my YouTube link up there. How does it work with the larger number? Because if I'm not mistaken, there's more beads on the vertical row. Was just about to ask if there was place values. Yes. So, Sophia, how does it work with a larger one? What do you mean? Like that, like this one, or long, like bigger numbers? It's all the same. It's all the same. Or are you talking about like longer because size matters? So this one is a 13 column one. It just means that I have more digits. That's all. That's the only thing. So if as an adult, I would probably invest in a 13 column, or I could do 23. I know there's a 21 column one. And if you're looking for bigger numbers, you could do it. Unless you're talking about this one. This is a teacher's abacus. Oh, I thought they were just taller. No, they're all the same. They're all the same. So this one is just a teacher's abacus, and it's just bigger, and so the kids can see it from across the classroom. And it works exactly the same, except I have a movable marker. This one, my marker. Have a good night, Yessie. There's a marker here. There's a indicator right here on my student abacus. That marker is what tells me where the ones place is. And I can choose any of the dots to be the ones place. On the larger one, you can choose, yes. So I can move my not decimal, my ones place. Because after the ones, then it will be this decimal sits between the two columns, right? In technically speaking. So if I did my ones here, then my tenths and my hundredths would be here. And it'd be the same thing for here. So I have my ones. If I chose this as my ones, let's see if I do that. If I chose this as my ones, then I have my tenths and my hundredths, and the decimal sits between the two columns. Does that make sense? So, yeah. Okay. So, and then if you look at this 13 column one, I have multiple places that I can choose a decimal. I'm sorry, I can have multiple places to choose my one. So I can choose one here or here or here. It doesn't matter where your home is. It doesn't matter where your ones is. You just need to choose one. Just like a Pokemon, right? I choose you and you choose that Pokemon to help you battle. It's the same thing with these decimals. I'm not decimals. It's the same thing with these dot indicator. You just choose one of them and then you'll be able to do it, right? So if I chose this dot indicator, then I have 13 columns. I would have ones, thousands, millions, billions, and trillions. If I wanted to track the national debt, I would use a 23 column abacus. And I would have again, the ones, the thousands, the millions, the billions, the trillions, and so forth. So the bigger the abacus, the more columns just means the more digits. That's all that means. So the reason why I would have a small one for the kids because the questions are smaller. That's all. You could use the same questions on a bigger abacus. You just use less columns. That's all. So anybody else have any questions? Thank you so much for the comments. Thank you so much for the comments. It's nice to be able to have a conversation about all of this stuff. So the first thing we're going to do, so the next thing we're going to do is, if you notice, I have my 4. We can take it a step further, right? We could take it a step further, and what we could do, hey, educated, opinionated RN, welcome back. I see you. Okay, so we're going to have our next question. Our next question will be 2 plus 4. Again, what we're looking for is we're looking at the add-in. This add-in is what we need to understand, right? It doesn't matter about the first part. Why? Why? Because we have enough. So there's my 2. But now the question is plus the 4. I don't have enough beads to add the 4. So what do? I go back to what I remember. I go back and I do a deep dive. And this is what we want to do, is we want to put this in our working memory. No, we want to put this in our long-term memory. Like, my kids know how to do this, but can they explain it to you? No, because now it's become ingrained and they just know how to move the beads. So if you give my kids an abacus, they'll know how to move the beads. Can they explain? Is connecting. Ugh. All right. All right. I'm back. I am hopeful I am back. Okay. So we'll see. We'll see. Okay. I have to take anyways. All right. So we're back to here. We're back to here. We want to add the 4. Again, we're going to do a deep dive. What does that mean? We already know this concept. So what we need to do, again, we don't need to know our doubles. What we need to know is how to add a 4. So what we're going to do is we're going to plus the 5 minus the 1. And our number is 6. Our answer is 6. Now, why is this good? Because when we add, we can subtract, right? So memorizing your doubles is fine, but there's no such thing as negative doubles. It's all just 0. Make sense? So the question is, what will happen when I want to minus 7? So 7 minus 4. Well, I don't know what that is. Yes, we do. We know the concept of adding a 4. Now we just need to reverse the operators. So if I minus the 4, it will equal to minus the 5 plus the 1. So we see a relationship when I add a 4 and I take away the 4. It's the same, kind of the same. It's just the reverse. It's like mirrors. It's like opposite town, right? Hi, Kaya. It's like opposite, right? It's like a mirror image, I guess you would say. I don't know. I got to figure that one out. So if we have 7, when we have 7, I want to take away 4. I cannot take away 4. What am I going to do? I'm going to utilize the lazy bum number 5. I'm going to minus the 5 and I'm going to add the 1. So my answer is now 3. So what did we just do? What we did is we connected the add-in. I know how to add the 4. I now know how to minus the 4, and my answer is 3. So again, we go back to understanding how to do the add-in. That's it. That's it. That's about it. I mean, there's more. Hi, Ethan. There's more, because after the 5, can you show how likely 2 times? You know what? 2 times 3, you have to memorize your multiplication. You need to memorize your multiplication fact. However, what we can do is we can do, let's say 23 times that by 8. We can do this. I could show this to you on the abacus. So we could do that. The first thing we need to do, thank you, Sophia, for the question. What we need to do is we need to understand where are we going to put our answer. To put our answer, we need to count our digits. Is this question okay for you, Sophia? Okay, great. I just want to make sure because I don't want to. So what's going to happen is we need to find our starting point. We need to know where to put our answer. Why? Because in regular math, in regular mainstream math, what we do is we do 8 and we do it this way, right? We do the 1s first and then we do the 8s. But in abacus, we don't do that. In abacus, we go outside first. That's what we're doing in new math is what they call it. But new math is really abacus math, just in disguise. New math is actually abacus math written out. That's what it is. Why? So now we talk about our place value. 1, 2, 3. We know we're going to be in the hundreds. Does that make sense? We're going to be in the hundreds. So the answer is going to be right around here somewhere. At least it's a ballpark. Right? The idea is to know ballpark, where's my answer going to be? So my answer is going to lie right around here. So I'm going to be 1, 2, 3. How do I know? Because it's 1, 2, 3. We add our digits together and we start with the third column. Now the first thing we do is we do 8 times 2. That's what we're going to do. What is 8 times 2? 8 times 2 is 16. I add 1 and then I add my 6. Now what do? 8 times 3. 8 times 3 is equal to 24. I add 2 and then I add 4 and that's it. My answer is, if you can tell me how to read this, tell me what the answer is. Now, as people are writing that out, the difference is we don't say 8 times 20. There is no point. Now it's just being overwhelming. The point is, we only need to say 8 times 2 because that's what our multiplication fact is, right? That's the multiplication table. We don't have a multiplication table that says 8 times 20 because then it's just too much. We don't need to memorize what 8 times 20 is. What we need to do is we need to understand where to put the abacus, where to put the beads on the abacus. So when we do it in new math, they write it out. It's 8 times 20. So here, if we look at it, it's 160. But if you notice on my abacus, I already added the 160. I don't need to worry too much about the place value. So in the comments below, what number do we think this is? Do we know what my answer is? 184. Exactly. Thank you, Sophia. Thank you. And that's what it is. It is 184. 184. Thank you. So did you notice that we didn't have to say 8 times 20. All we had to do is say 8 times 2 because we have it here. We can do another one if that makes sense. Kat, are you still with me or have you gone to bed? Because I know, it's a little late. It's a little late. We do some midnight math. I do some midnight math. Hello, Bliss. All right, we can do another one. So if we do another one, let's say, I don't know, 59 times that by 7. We'll do that. It's the same thing. Same thing. And again, what we're going to do is we're going to find our starting point. So I don't know what I'm doing. There we go. There we go. There we go. So 1, 2, 3. 1, 2, 3. So I'm going to put here. What we're going to do is we're going to do 7 times 5. So 7 times 5 is equal to 35. So I add 30 and then I add my 5. And then what do? I do 7 times 9. 7 times 9 is 63. This is going to be a little much because we didn't talk about how to make a 10. What do I mean? Well, if you look, we're going to add the 6 and we're add the 3. I'm going to add the 6 and I'm going to need to add the 3. I'm going to add the 6. Well, I don't have any more beads to add the 6. This is where we had to know our addition, right? We have another math fact that we need to do. We know that 6 plus 4 is equal to 10. This is what we know. The pairs. Yes, TNG, welcome back. It's the pairs. Yes. And so when we isolate the variable, we're going to do 6 is equal to plus the 10 minus 4. The next generation. Are you talking about the next generation was the best? I was thinking about that and I was like, ooh, I wonder if you're talking about the next generation. Okay, so we're going to do 6. So plus the 10 and then take away the 4. Take away the 4 is not enough. So what do we need to do? We need to minus the 4 is equal... Whoa, I was right. Minus the 4 is equal to minus the 5 plus the 1. So we're going to minus the 5 plus the 1. And then we need to add the 3. Whoop, whoop. Oh, yeah, Jean-Luc Picard was the best. I never watched Picard. Did you? To beam up Scotty. Yeah. 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 I remember that. Okay. Yeah. So what we just did was a little bit about addition, but these are the fundamental addition formulas that we need to know. But because we skipped past it, we may or may not understand this. But that's the idea. So then my answer is, who knows what my answer is? So, hey, TNG, did you ever watch Picard? I never really quite get to... I didn't see, okay. But I have seen all the Enterprises, TOS, Voyager, TNG, and DS9. Really? You like DS9? I couldn't get into DS9. I did like Enterprise with Scott Bakula, I think his name is. I liked him from Quantum Leap, but after that, it was kind of like, eh. And then I liked TNG when they had the Borg. That was really... It was so emotional. I was so emotional with that. And it got kind of creepy with the eyes and anyways. TOS. I don't know what TOS is. I never really got into the Voyager. I couldn't get into Janeway. Yeah. I think I only stayed with... I tried a little bit about Enterprise, and I did all of TNG, but I think that's as far as I got. And I'm trying, So, anyways. DS9 was my least favorite. Voyager was very good. Really? Okay. Yeah, I heard good stories about Voyager. Okay, I also have to go. Okay, Sophia, thank you so much. This was interesting. Yes, thank you for the question. Thank you for the question, Sophia. I do appreciate it. Yeah, I'll see you in my next live. But it was really interesting. And I'm not sure if Kat's still around. Kat, you're being very quiet. I don't know if you have any questions. But we can go back to adding and subtracting, if that helps. Yeah, because... Yeah. So let's do a little review. I'm trying to do it different. 2 says the original. Oh, okay, I see. Okay. Gets the Trekkie and the Trekkers. Get into the Trekkie and the we try to get the kids to watch the original ones, and they were like, this is boring. And I'm like, eh. And then I try to watch the Next Generation now, and I don't think the kids would enjoy it because it's just... Anyways. So... They didn't like the Voyager. They liked the movie Voyager with Chris Pine. So, and I'm like, oh, okay. Because, it's a little bit more flashy. Okay. Lower Decks, I guess, is for the... Yeah. Okay. So what we're going to do is we're going to review counting. We have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar is considered counted. So you might be asking, what happened to 5? Well, 5 will always be the top bead no matter what. So this is 5, this is 5, these are all counted. These are all counted as 5s. But notice, now there's too many 5s. But if we're going to continue to count, I'm going to clear it out, and this is my 0. So if I have 5, then I do 6. If you notice, this is 5 and 6. 5 plus 1 is 6. And then 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. So all together is 9. Hey, Miss Carmen, welcome. Io, do you have any question? I know you've been quiet too. All right. or his brain just kind of splattered on the wall and just doesn't can't think anymore. But it's kind of interesting. Like I find, but I think adding is a little bit, adding and subtracting I think is underrated, and I think it needs to be explored a little bit more. But it is what it is. So this is 10, and then this is 11, 12, 13, and 14. Now we have 14, we have 15. After 15, I agree. Oh yeah, right? I think so. I think the other thing is we push the kids too quickly to understand the abstract symbols, which means the numbers themselves, right? I think we need to continue to work with the concrete of the formulas and of the numbers. And I think it's just helpful. In Abacus, in our curriculum, in the Abacus world, we use our Abacus all the way to multiplication division. And I don't know, we don't push our kids to go straight into mental math. And I think that's the one thing that we really try to push the kids to be like, think about the strategy of like adding and stuff. And it's like, that's a lot of work. And that's also depending on their age. So like in Abacus, we actually have set formulas that we tell the kids to memorize. We just tell them to memorize it. So the first thing we need to do, right? We know how to count. So this is 15. This is 25. This is 35. So are we okay, Miss Carmen? Like how we're doing this? And then we can do this, right? This is 535, just to keep an idea of where we're going. And what we could do is we could start doing adding, subtraction, multiplication, and division. I'm okay. We have, oh, yes. Yes. Okay, good. But it makes sense, right? So, well, I wanted to know how fast I can go. Because I wanted to go into like, we can go into as far into division, or we can go as far as to subtraction and addition. So here, I'm wondering, are you a teacher as well? And if so, what grades? If you have fives, tens, that's 50. If you have fives and tens, that's 50. Well, if I have 50, that would be 50 right there. That's it. That's all I would need, right? But five tens, yeah, that would be 50. And then 60, and then 70. And then I did here. So every place value is, every column is a place value. So we have our ones, our tens, our hundreds, our thousands, our 10,000. So when we look at it, just as TNG said, this is 50 in the tens column. But if we choose this as my ones column, then this would be 50. And then everything else would be the decimal. So when we look at it, we want to pay attention to where our columns is and what dot indicator we choose. Just like a Pokemon, right? You choose your Pokemon to help you battle. You choose your dot to figure out your perspective, to figure out where you're going to start. So you choose a home, you choose whichever one, it doesn't matter. So it's just like in the bigger abacus, this is a 13 column abacus, you can choose any of these dots. These are available to be housed. So these are all my ones. I could do one here or here or here. It's a one, not everywhere, right? So the idea is if I choose this one to be my ones, then I can have all these numbers to be my digits and might have a really big answer. Now, if you notice there's a dot here, that means that I'll have it grouped. It'll have it grouped. So I have my ones, my thousands, and now I have my millions. Does that make sense? So it's easy to see and to be able to categorize because now I have something labeled. If I chose this to be my ones, then it'd be my ones, my thousands, my millions, my billions, and my trillions. So it will fit multiple problems. It will not fit multiple problems. It will fit multiple digits. So you can have as many digits as this holds. So let's say we had 3, 4, 5, 6, 7 plus 4, 9, 8, 3, 2, right? So 1, 2, 3, 4, 5. If we did it here, 1, 2, 3, 4, 5, it might be a little questionable because we don't have any more beads over here, right? We don't have any more columns. So that's why I would switch to this one because I have more columns I would need to use. So it'd be 1, 2, 3, 4, 5, and then if it spills over to this next column, then I have it. Does that make sense? So it's not the multiple problems, it's the amount of digits to the problem. So, and that's what that means. Right. And then if you really want to track if you wanted to track the national debt, you could do 23 columns. Digit overflow. Yeah. So that would be like carrying on or borrowing or grouping or regrouping. So when we do the 10, right, when we do a plus 10, when we understand how to make a 10, making a 10 is actually grouping and regrouping. And it's really quite easy because all you're doing is adding a 10 or taking away a 10. So let's continue on with adding. So when we're adding, I'm going to cover this. When we're adding, we'll notice that we have 1, 2, 3, 4. And then if I want to add the 5, I just add 5. And now I have 9. So what we're doing is we're doing simple adding. That means that if I have enough beads, then I can add it. And so if I did 2 plus 2 is 4. I don't need to memorize my doubles. I don't memorize doubles. What I memorize is our formulas. There's a set of formulas to be able to work the abacus. And it helps to understand the formulas because it's the fundamental moving everything around to make it what we're trying to do, to make it work for us. So to continue on the idea of understanding the add-ins. So here my question starts with plus 2. Starts with plus 2. My question starts with plus 5. So I'm going to add the 5, and here I'm going to show how to add a 2. So when I add a 2, all I got to do is move these 2 beads. But then the question is what happens when there's not enough beads? What happens when there's a question with not enough beads? That's when we get into, let's say, 3 plus 4. So let me rewrite this. So we have a question called 3 plus 4. Now the idea is not to memorize your doubles minus 1 or the strategy of doubles minus 2. We don't do that. What we do is understand how to add this 4. We have a concept that we're teaching the children. It's 4 plus 1 is equal to 5. I'm sorry, I wrote that. So what we're going to do is we're going to isolate this variable, this 4. That means I'm going to make the 4 and I'm going to make it stand for something, right? So what's going to happen is I take this 1 and I move it to the other side. So I will rearrange my formula to say when I want to add the 4, I can add the 5, right? I'm going to add the 5. But adding the 5 is too much. So what do? We need to balance the equation. So we're going to minus the 1. What does that mean? Hey, Ethan, welcome back. Good morning. So when we add the 4, what we're going to do is we're going to add the 5 and take away the 1. That's it. That's all we're going to do. So then my final answer is 7. Did that make sense, Miss Carmen? So what we just did is we understand how to utilize this concept. We're utilizing this formula. When we utilize this formula, it's versatile, and we can make it into, we can utilize it in other places, right? But we don't need to work on too many strategies. We have this one formula and we'll be able to use it. So let's take it one step further. Let's do 2. So if I did 2 plus 4, plus 4, sorry, 4. So again, if I have 2 and I need to add the 4, again, I don't need to know our doubles. I don't need to be like, okay, 4 plus 4, then minus 2. I don't need to do that. What I need to do is understand if I want to add the 4, I just go back to what I just learned, which is plus the 5 minus the 1. So all I have to do is plus the 5 and then take away the 1. And then my answer is 6. So, sometimes people are really like, that's really complicated. It's like it's only complicated in the simpler questions, but the kids won't see that. They won't understand it. So if we give them a solid foundation on how to add a 4, then we can go forward, right? So just like if we want to add a 4, the question is if I have 5 and then want to add the 4, is there enough beads to add the 4? What we are doing here in Abacus is we're providing critical thinking. Can we add the 4? If not, how can we? Just like how Bob the Builder, can we do it? Yes, we can. So that's the thing. Can we do it? Yes, we can. So we're going to add the 4. Now we're going to do it again. Can I add another 4? No, I can't. Well, how do we add it, right? So here we're going to add another 4. We have 9. So if I have 9 and I want to plus the 4, what are we going to do? Well, can we add the 5? No, we can't because we're utilizing the 5. So the next set of questions that we need to do is we need to understand 6 and the pairs. We did this before. 6 plus 4 is equal to 10. So what happens is I want to isolate this 4, so I'm going to take this 6 and move it to the other side. So that means I'm going to rewrite it plus the 4, that's what this is equal to add the 10. But when we add the 10, which means this column next, that's too much. So we need to minus the 6. So I'm going to take away the 6. And now my answer is 3. You get 1, 10, and 3 ones. Exactly. Exactly. Right? So the idea is to also see the number pattern. My answer is 13. You will see the number pattern. I want to take away 6. However, because we know how to add, we can subtract. So what does that mean? If I have the question 7 minus 4, I know how to do this. How? Because I have this concept that I already knew. All we're going to do is reverse the operators. So we're going to do minus the 4 is equal to minus the 5 plus the 1. So if we have 7, I'm going to minus the 5, I'm going to plus the 1. And now my answer is 3. We can do it again, right? We can do it again. So if I had 13, if I had 12, let me do 12, right? If I had 12 and I take away 4, 12 minus 4, what are we going to do? Well, let me clean it up a little bit. There's not enough beats to minus the 4. Can we take away the 5? No. See, there's the critical thinking that we're building. We're building critical thinking with our questions. These are simple questions, but there's more to it. There's an environment around it where we can start bringing in lessons to understand, critically think. Can I do it? No. How can I do it? So if I can't take away the 5, what's another way? We know this, but now we need to know the inverse. So that means it's minus the 4 is equal to minus the 10 plus the 6. So I'm going to minus the 10 and I add the 6. My answer is 8. We okay? Does that make sense? Miss Carmen, are you okay? Kat? Io? It's very quiet. I feel like I'm in the library. There's no 5s place. Correct. So if there's no 5s, that's why we go to the 10s. Right? Because we cannot take away the 5. There's no 5 to take away. So that's why we had to go to the 10. Yes. Abacus is base 10. Abacus is base 10 because it's a decimal. I just got here. I'm so lost. Oh, I'm so sorry. Let's read how the abacus, because your number is 123.05. That's what I see. User 123.05. So what we're going to do is understand how to read this. Hey Samantha, so what's going to happen is anytime the beads are touching the bar, we're going to count it. So we have 1, 2, 3, point, right? It happens between the 1s and the 10s. So there's my decimal, 0, 5. Does that make sense, user? So thank you, Riley, for sharing my live. Does that make sense? Are we okay? So when we're counting, we have our 1s, our 10s, our 100s, our 1000s, our 10,000. So when we count it, we have 1, 2, 3, 4. And then all the top bead always has a value of 5, no matter what. Always a value of 5. So we can count higher now. We can do 5, 6, 7, 8, and 9. Oh, you're welcome. I love this life. Oh, I love this life too. Minute. But everybody's so quiet. I feel like I'm in the library and I'm like, I don't know if I should be talking. Okay. No, thank you. I appreciate you. I appreciate the compliment. Thank you. So user 123.05, does that make sense? So when we look at it, we have our 10s. So this is 10. And now we can count by 10s. 10. But see, it's the same, right? This and this is the same. It just happens to be in different columns. Is it a 6, 7? Oh, it's not a 6, 7. I'm going to keep using it till it's no longer funny or till no longer it's trendy. Yes, it makes sense. I'm learning something new today. Yes, good. So when we talk about it, right, we have 10, 20, 30, 40, and then this is 50. Sometimes you have to be careful because sometimes I have fat thumbs, fat fingers that I accidentally move my columns. But you want to try to keep your fingers on the column that you're using. And it's about it's also about having attention to detail. And so my eyes are a little old, so I have to like kind of do this a little bit, make sure I got the right beads. Okay, so this is 70, 70, 70. Why? Because of the columns, right? Now, if you notice, we have this indicator. This indicator tells me it's the ones place. You could choose this one like a Pokemon, right? You know, you choose a Pokemon to help you battle. You can choose this one to help you battle. You can choose this one to help you figure out where your ones is, where your home is, right? You want to just pick one. You only want to pick one. You don't want to pick two because then you're just confused. You just want to pick one. You can choose this one or this one. It doesn't matter. Just choose one, right? Just like choose a path. So the idea is if I choose this one, right? If I choose this one, then this would be my ones, my tens. Then I just move everything over. This would be my ones, my tens, and then I'd have my decimal here, and then be tenths, hundredths, and so forth. So user 1230.5, I can only do 230.05, and then I have more numbers. Does that make sense? So the columns, the only reason why you have more columns is depending on how big the number is. It just depends on how big the digit is, right? So you can have a 13 column abacus, and it's the same concept. All the top beads is a value of 5. It doesn't matter what it is. So on a 13 one, I like to stay in the middle. In the 13 one, I like to be here in the middle because I have all these numbers to be big and all these numbers to be small. Make sense? So if I wanted to talk about how much money I wish I had, I would like to start here. So I have my ones, my thousands, my millions, my billions, and my trillions. I would like to have $1 trillion, please. Right? Or if you wanted to track the national debt, you can use a 23 column abacus. And then, hey, your mom and Sarah. So you could track the national debt with the 23. I'm not sure how far it goes. I think we're at trillion, right? But that's the idea. This one is made out of bamboo. This one is made out of plastic. But they work exactly the same. They're all just the same. The color has no meaning either. The color is just easier to see because we're on the video, because you're on the video, because I'm on video. But it's also easier to talk to kids because the kids. Oh, sorry, that was not an earthquake. Because the kids that I have in my class, they're 4, 5, and 7, and so through Zoom, it's just easier. It's just easier to say move the green bead, as opposed to I had this one that says, well, move the brown bead. Anyways, but yeah, they work exactly the same. And the idea is when you have an abacus, hold on to it. The reason why is because it's very simple. It's very easy to move your beads. So any jerk, you're going to lose your answer. And I'll be like, my answer. That means I got to do it again. So that's what that is. So we talked about this. We talked about, is there any other questions? Any questions at all that you guys want to talk about? That's abacus driven or next generation. Or Lord of the Rings. I love Lord of the Rings. If you have an abacus that's big, like a 10 bead, we can do modification. Please, what are we doing? Because I can continue on counting because I know how to really count well from 0 to 9. I've been teaching. Can you show me how to solve a math problem like addition? Yeah. Okay. So let's do some addition. The first thing we need to do is understand that we have formulas. So these are some of the formulas that we're going to do, and I'll walk you through it. No, not a problem. Don't worry about it. We're going to walk through it. So what's going to happen is understanding that in school, we're teaching children. Here's the secret. We're teaching children how to make a 5. how to make a 5 is plus the 1 is equal to plus 5. I'm sorry, 4 plus 1 is equal to 5. That's it. We're just teaching them that. We do another one, 4, and we do the reverse, right? Is equal to 5. And then we do another one. 2 plus 3 is equal to 5. I'm like, why are you showing me this? It's like, it's critical. This is a very key thing. This is a key item. Why? Because if you notice, we have this thing that doesn't break. The keys to the kingdom. The keys to the kingdom. That's funny. Okay. So what does this mean? Well, in school, we're doing this, right? But what happens is Abacus will actually supercharge it. And I'm getting better at putting in my lightning bolt. So what we're doing is we're supercharging it. Why? Because I don't want my numbers to be bums. I don't want my numbers to be lazy bums. I want them to work for me. What does that mean? Well, what's going to happen is I'm going to isolate this variable. The first thing I'm going to do is I'm going to isolate this variable. Isolating a variable, it sounds very much like algebra, but we're not doing algebra. I promise you. We're doing algebra-like. When I teach the kids, they don't know what this is, right? We're just going to teach them, know the formula. But because I'm talking to adults and it's funny, we are going to talk about a little bit about algebra. So we're going to isolate the variable and then we're going to move it to this side over here. So I'm going to rewrite this equation and we're going to do 4 is equal to 5, right? But 5 is not good. That's not balanced because this is an equation. When we want to add the 4, we want to balance it. To balance it, I want to minus the 1. So what we just did is we balanced the equation. We isolated the variable. What variable are we isolating? Well, let's say we want to do 3 plus 4. Wait a minute. I know what I'm doing, right? This 4 looks awfully similar to this 4. What does that mean? Now what I could do, there is no 5. Yes, there is no 5. There is no 5. But I can substitute this into here. So when I have my number 3, I don't have any more beads to add the 4. We're stuck. But we know a formula. This is the formula. This is a foundational building block. So what we're going to do is we're going to add the 5 and take away the 1. And now my answer is 7. And then you're like, wait a minute, that's really complicated. It's not complicated because now we can scale it. When we know the fundamentals, we will be able to scale it when the numbers get bigger. So when the numbers get bigger, they can get really big, right? This is 5 digits right here. But we need to understand this first. Let's take it one step further. Let's do a 2. Same thing, right? If I do 2 and I want to add the 4, there's not enough beads to add the 4. Well, what do? I know how to add the 5. So all I got to do is plus the 5, take away the 1. Right? Are we still 6, 7 about it? Does that make sense, user 123? And I don't know what your emoji is. Drop the 1 and the 5. Yes. Yeah. Yeah. Yes. So what I would just say, and exactly what I would say is what I would do, right? So it'd be plus the 5 minus the 1. So TNG, instead of saying drop 1, 5, very 6, 7. So, but TNG, what I would say is not drop 1, 5, because it gets a little confusing. There's a lot of numbers there. What I would say is plus the 5 minus the 1, like that. Plus the 5 minus the 1. That's what I would do. That's what I say, right? Make sense? So yeah, 6, 7. So this is 6, and then this is 7. 6, 7. I'm going to keep using it because I'm retarded. I'm sorry. Was that? No, sorry. Flawless. Yeah. So then the thing is, let's go to the next question. Well, what do we do after this? Let's do a takeaway. Why? Because we know how to add a 4. What are we going to do? We want to do 8 minus 4. Well, notice we don't memorize our doubles. What we do memorize is now we have this concept of plus the 4 is equal to plus the 5 minus 1. So when we know this, there's the inverse. There's not an inverse for the doubles because a doubles minus just means 0, right? but a doubles addition is an answer. However, in abacus, we know what the minus is for this. What does that mean? Well, because we know that there's a plus 4, there's a minus 4. All we need to do is reverse the operation. We just need to make the operations opposite. So we're going to minus the 4 is equal to minus the 5 plus the 1. Multiply two negatives gives you a positive. Yes, but we're not multiplying. We are taking away and we're subtracting. So we're not multiplying here. What we're doing is we are reversing the operation. So when we add, we can subtract. So here is the question is 8. I want to take away 4. I cannot take away the 4. To take away the 4, I need to minus the 5 and I need to add the 1 back. So I'm going to minus the 5, add the 1. My answer is now 4. So, yeah, multiply two negatives gives you a positive, but we're not taking it away here. We're not multiplying here. We are just reversing our operation. I have to go. Oh, yeah, thank you so much for joining. User 123. Yeah, have a good night. I'm happy you learned something new. I hope to see you in my next live. So does that make sense, TNG? My frontal lobe expanded. Yeah, it's great to have like conversations to see what people will talk about, right? And it's just interesting to like how other people see, because I mean, I've been teaching abacus for 20 plus years, but I've only been teaching kids, and kids don't really comment and ask questions and be like, wait a minute, because they don't have different variations running through their head. Whereas as adults, we have many ways that we're thinking, right? We have many ways of understanding how we're going to add certain things. And I'm not trying to debunk how to add. I'm just trying to find a different way. I'm trying to abacify the world. Yeah, I'm trying to popularize abacus so then, we can have it more mainstream. Abacus mode. Yes, abacus mode. And it's interesting. I mean, if like to continue on with the whole concept of new math, the only one that I can really, the only one like, I don't know. I don't. I think I think they're overcomplicating the idea. Why? Because they really want the kids to understand quantity, which is fine. So let's say we had like 23 plus 48. So in new math, what are they doing? Well, we got to break this up. So 1, 2, right? These are tens, and then 1, 2, 3. And then we do 40, 1, 2, 3, 4, and then we do 8. 1, 2, 3, 4, 5, 6, 7, 8. I think the difference between this and the abacus is that it's still a picture. We're still trying to translate the dumb picture and try to make it more than what it is. And it's difficult because pictures are very difficult as opposed to the concrete. So here we would have to combine it and all this and that. Whereas if I did it here, I said 23, I'm going to put 20, I'm going to put 3. I see it, I know what I'm doing. So I want to add the 4. I know how to add the 4. I add the 4 is plus the 5 minus the 10, minus the 1. Why would I do that? Because I could see it. I can add the 5 and I can take away the 1, right? This, I can't take away. I don't know what I'm doing here. I'm putting it all together, and I would still have to count 1, 2, 3, 4, 5, 6. I would have to count it, right? There's no, to me, there's no. It's just difficult to see. This is now just a rant. So here we're doing 3 and then plus the 8. When we're at the 8, there's not enough beats to add the 8. Well, okay, what do we do here? Well, we have to count it. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have 11 dots here. So then what do we do? Well, we got to take this dot, we got to take this one, and we got to move it over here. I feel like it's really complicated. This one, I want to add the 8. We know why so many, this is why so many people are broke, if you ask me. Makes sense. Yeah, I don't, I know it's a rant. I go off this because I know people are teaching this. I'm not discrediting it. It's just using this makes sense when the kids are small, but when they're a little bit older, this is too much for the eye. This is way too much for the eye. It overcomplicates things. So here I want to add the 8. We teach the kids, how do you make a 10? We teach them how to make a 10. This is how you make a 10 plus the 2, whatever, right? We're going to isolate the variable, make this and move it over here. 8 is equal to plus the 10 minus the 2. So what am I going to do? Plus the 10, take away the 2. And my answer is 71. 71, right? Thank God I was never. Yeah, right? Like I'm so confused. I'm like, that's a lot to look at. I'm not dumb, but I'm not. That's overwhelming. And so they were talking about this, and then people are like, well, we want the kids to understand the fundamentals of like how big it is. I'm like, honestly, I mean, as much as it is, I don't think we know the quantity, how big 1,000 is, right? I know what 55 miles an hour it is because we feel it. But how big is 55 miles? I don't even know. I only know how big a mile is because I know it's 4 times around the track. So I think a lot of it's the fundamental of yeah, especially for bigger equations, right? Like yeah. Yeah. I mean, it's the same thing with these, right? They have these that they were playing with, and it's like it's fine, but the problem is you still have to count the dumb things, right? Like I don't even know how much I gotta count. 1, 2, 3, 4, 5, 6. I have 7. I have 70 right here, and it doesn't. There's no such thing as place value. Like it just blows my mind. We're doing all these manipulatives and nobody comes in and says, let's try the abacus. Which I guess is what I'm trying to do. I'm trying to fill that void. So imagine drawing, yeah, right? 100 dots with each equation. Right, exactly. It's fun to play with. And then I was talking to a friend who's a teacher as well. And they're like, it's hard to manage these things because the kids will do everything with it. They'll eat it. They'll shove it up their nose. They'll throw it away. And then you're stuck. And then what are you going to do? Anyways, that's a little bit of a rant. Sorry. And then there's new math, and that's what makes me mad. So new math, I don't know if I told you, TNG, about new math, about what they're doing. So we had our question. Let's do some multiplication. Let's do some big multiplication, right? Let's do, I don't know, 4 times that by 39, 6. Let's do that. They use the slide rule, I guess. Yeah, I've never learned the slide rule. I heard that the slide rule was great as well, but then it never stood the test of time, right? Is there a slide rule competition? I know there's an abacus competition. I know that for sure. It's all over the internet. I mean, I had one and I was a part of one, and those kids are crazy. And then there's not a slide rule person that is competing with Bill Gates and a calculator. So I would beg to differ that slide rule and abacus are similar. They're not, because slide rule never stood the test of time. Abacus has stood the test of time. It goes all the way back to when we were bartering, after we bartered, right? And then we started talking about business, absolutely dissimilar. Yeah, right? So I don't know how to use the slide rule, but abacus stood the test of time. Like we started talking about abacus. What is abacus? Abacus is really just moving of pebbles, right? And then as we start growing and stuff. Oh, anyways, so I'm back to here. So in new math, and this is what makes me mad too. It was so like, it makes it so difficult. So I need this one. We know how to count it. 1, 2, 3, 4, 5, 6. So I know I'm going to be in the 6th column. 1, 2, 3, 4, 5, 6. Right? We know we're going to be here. Now, new math does the same thing with abacus math. New math does this. The left side first. But the problem with new math, I find, is they do 200 times that by 300. I'm like, what the shit is that? Sorry. I don't know if I'm allowed to swear in TikTok lives, but what are we trying to do? Like, this is crazy. Now, the reason why, I know why we're doing it. I know why, because we're writing it out. But in Abacus, we don't need to write it out. We know we're going to be here. So all we need to do is pay attention that 2 times 3 is equal to 6. 6 is a single digit. I go back one column and I add my 6. That's it. That's all I got to do. Because it keeps track, right? So then we do the next one. 3 times 3. We don't say 300 times that by 30. I'm already confused. It's just 3 times 3 is equal to 9. 9 is a single digit. I go back one column, I add my 9. And then 3 times 4. 3 times 4 is 12. 3 times 4 is 12. Nowhere in our multiplication table do we talk about 300 times 4. We nowhere. Now we're just adding complications. And then after they do this, they have to add it all. I'm like, what? Whatever. So we're going to add 12. We add 12 here. Add the 1, add the 2, add the 1. What is plus 1? Plus 1 is equal to plus the 10 minus 9. Why? Because we already have the 5. So what are we going to do? We cannot add the 5. We need to plus the 10 minus the 9. And then add the 2. Okay, I'm done. I'm done with the 3. Now what are we going to do? We got to recount. I'm going to change a different color. I'm going to recount. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. We do 9 times 2, right? 9 times 2 is equal to 18, plus 1 plus 8. 9 times 3 is 27. 9 times 3 is 27. I add 2, I add 7. Uh-oh. I think it's this one, right? Yeah. I add 2, I add 7. There's not enough to add the 2. What do? Plus the 2 minus the 8. Minus the 8 plus the 7. So I added the 7. And then what do? 4 times 9 is 36. So I add 3 and I add 6. I add 3. Can't add 3 because I have the 5. So 3 is equal to plus the 10 minus 7. So I plus the 10, take away 7. And then I plus the 6. Now I'm done. I'm done with this one. Now I got to change another color. Right? And I got to count again. 1, 2, 3, 4. 1, 2, 3, 4. So what am I going to do? 6 times 2 is 12. 6 times 2 is 12. I add 1, I add 2. I add 1, I add 2. 6 times 3 is 18. 6 times 3 is 18. I add 1, I add 8. I add 1. There's not enough. What do? I'm so sorry. I add 1. Add the 1 is plus the 5 minus 4. Plus the 5 minus 4. And then plus 8. There's not enough beads to plus the 8. So I need to plus the 10 minus the 2. So I plus the 10, take away the 2. Plus the 10. And I cannot take away the 2, so minus the 2 is equal to minus the 5 plus the 3. Minus the 5 plus the 3. And then my final question is 6 times 4. 6 times 4 is 24. So I add my 2, I add my 4. I add 2. We know how to add the 2. So it's 2 is equal to plus the 5 minus 3. So I plus the 5, take away the 3, and then I add my 4. That was a little bit of a rant. But it's only because we get into this new math. There's no way. It just annoys me. I'm hoping this is the right answer. 1, 2, 3, 4, 5. So hopefully that's the right answer. 9, 2, 6, 6, 4. I've been moving it up and down, so I don't know if my abacus actually moves. So, new math seems very mechanical. Yeah, I think so. And it really annoys me because they're making it. I don't know. I think they're overcomplicating something that can be done, with algorithms. Because the problem is, understanding this is the steps for abacus, for algebra. This doesn't help us with algebra, right? It's great, we understand, but I don't know, just I'm just so upset. I'm so upset with new math and how there's like this new wave of new math, and yet abacus doesn't have its say, you know? Like I feel like the abacus is like the stepchild, the forgotten the redheaded stepchild of the world. So, but it is what it is. I mean, there's a reason why I'm here and I'm so passionate about Abacus and trying to move and try to tell everybody what it's all about. And you know, maybe one of these days it'll go into mainstream math and it won't be so difficult for teachers to learn it, because that's why I try to build my books. I'm trying to build my books so then it's easy for the teachers to be like, "Oh, that's all we're doing? That's all we need to do." So, we'll see. We'll see. But that's the goal. All right. It seems like it's just you and me. I was kind of probably sleeping, and then the other one kind of slept. Oh, there you are. I wish I was taught abacus. It seems like a good way to learn. I think it's the greatest thing, because the thing is this, you could do it in your head, but in abacus curriculum, we tell you to do it on the abacus first. We want to make sure you see the beads move. As you remember and as you become more familiar how the beads move, then if you want to, you can take it away. Oh, hey, Bill. Hey, Bells. I understand this more than any math that I've learned in my life. Oh, hey, thank you. Yeah, sorry, I just started going on a rant with this whole, like, new math. Sorry. It's getting kind of to me, but that's okay. So, Beal, if you wanted to, we can start talking about how to read the abacus. And what we could do is we're going to talk about 1, 2, 3, 4. This is just learning how to read the abacus. As you know how to read the abacus, then we can go into doing adding and subtraction. And so here is 5. All the top bead will have a value of 5. And then when we combine the two, like this is 6. This is 6, 7, 8, and then 9. After 9, we have 10. After 10, right, we have our ones, our tens, our hundreds, our thousands, our 10,000. So the abacus itself keeps the place value. It helps you track place value. Really, what the abacus is, it tracks your numbers. Excuse me, it tracks your numbers. All of this stuff that I'm doing here, we actually do it in our head. You can write it out. I wrote it out so you guys can see what I'm thinking, but really we're doing this in our head. And we only use these numbers, we only use the abacus to track the numbers, which is really interesting. I mean, fundamentally, the only thing the abacus does, it doesn't do any calculation. All the calculations happens in your head. And that's why it's the greatest thing next to sliced bread, because we are not relying on strategies to build. What we're doing is we're relying on our math facts and our fact families to do this. Answers on the horizon. Answers on the horizon? I'm not sure, but I understand that. So, oh, the horizontal bar. Yes, the answers are on the horizontal bar. Exactly. The answer is on the horizontal bar. But see, the thing is you're just moving the beads to make the answers work for you. That's it. Exactly. And so going back to here, we choose any one of these indicators to be our ones place. You could do this one and then it would look like that. Why? Because we would only have if this is my ones, then I have my tens, my ones, and then between the ones and the tenths is my decimal. So then what happens is I have my ones, my tenths, my hundredths, and then my thousands. And it's kind of nice because these separators, these indicators, help separate the numbers, just as we write the number 1,000, right? 1,348. We could do that. 1,348. Does that make sense? Hey, doot, dat, dot. So, Beals, did that make sense? So we continue on like counting and just understanding how to read it. Yeah. So that's the thing is the first thing we need to do is understand how to read it. After we understand how to read it, then we can start going into adding and subtracting. Because what it is we already know how to start. We already know how to simply add, which means we know how to move the beads. So if I did this, 5 plus 2, this is 7. 5 plus 4, right? 5 plus 4 is 9. So we're already doing simple addition. And we're just moving the beads so we could see what it looks like. So if I did 39 plus 5, plus 50, I just add my 50. That's it. I'm just adding the 5. But we look at each column. We look at each column for what it is. So in Abacus, we only focus on the add-ins. So what happens if there's not enough beads? Well, this is where formulas come into play. And that's what this is. So the formulas is what? These are concepts we're teaching children already how to make a 5. Where's my making a 5? There we go. How to make a 5. Oh, yeah, there it is. We're teaching children how to make a 5. All right. 9 is the top of the column. Can't get much higher than that. Correct. Correct. It's the same thing with just, even if you look at the numbers, right? Even if you look at the numbers, you can't go higher than that because in each column you can only do 9, right? Doesn't matter. So it's really it's interesting how simple and delicate and efficient the abacus is. And it blows my mind. Every time I think about it, it blows my mind. But we're teaching children how to add a 5. Now, why do we want to do it? We want to learn how to add the 5 because we want to utilize our 5 here. We're gonna make our 5 work for us. We don't want them to be lazy bums. We don't want them just to be hanging out. We want them to actually be utilized. So when the question is, we have 3. So if we have 3 and I want to add the 4, like this one. If I have 3 and I want to add the 4, so I have 3, I want to add the 4, what is another way? Well, we know we have to just utilize this 5. So we could do plus the 4 is equal to plus the 5, take away the 1. So this is a formula that we need to memorize. After we memorize these formulas, and there's a set formula. We have making of a 5 and subtracting the 5. Where's my... excuse me. So yeah, we have a 5. So this is a set of 5s. When I was in school, I always visualized the numbers in my head. This would have helped me a lot. Yeah. See, the thing is we push the children to the symbols. This is abstract, if you really think about it. This is really abstract. Hey, JB! Yes, midnight math. I have my abacus. It arrived today. That's fantastic. That's so exciting. That's so exciting. Beals. So yeah, and so I think the one thing is we push the kids to really understand the abstract symbol. This really, if you think about it, is an abstract symbol. 2 doesn't this symbol right here doesn't mean anything. But 2, we know that this is a concrete item. Just like we have our pictures, right? We know this is 5. There's 5. This one happens to be 5 cats. But yeah. It's just interesting on how everything is working and how, we push the kids to go really basic, really fundamental, which is like understand how these beads work. But then this actually doesn't go into place value, right? Whereas the abacus talks about place value. So, but yeah. And then we have formulas. So again, what we learned is how to add the 4. We need to understand what the add-in. And so depending on the add-in, it depends on what formula we're using. If I'm going to be adding a 3, then we have to plus the 5 minus the 2. Why? Because the 5 is big, right? And we need to balance it. So that's why we have different scenarios how to make a 5. Right? And these are the two, this is it. These are the 2 pairs, the 3 and the 2, or the 2 and the 3. That's the pair. And that's what TNG was talking about. He was talking about the pairs because you only have so many beads to work with. Exactly. And so we have the beads But see, the thing is it's not just the beads. We only have so many numbers. Somebody was saying that this is a 16 base thing. It's like, it's not 16 base. 16 base means that we cycle through numbers. We cycle through numbers, but there's nothing after 9. So like, I don't know if anybody knows HTML, but we have colors and it's a hexadecimal, right? So the hexadecimal for white is 1, 2, 3, 4, 5, 6. This is hexadecimal, right? This is hexadecimal. This is base 16. Why? Because we go from 0 to 9 and then A to F. That is 16. That's a 16 decimal. That's base 16. Abacus is not base 16. It's only base 10. Why? Because it's all decimal based. Yeah. Somebody was trying to tell me. And it's like, well, you roll over to 16. I'm like, no, you don't. Because you do 1, 2, 3, 4, 5. This is 6. I'm sorry, this is 5. So what we do is we do an exchange. This is 10. This is 10. This is 6, 7, 8, 9, 10. This is still 10. It's still a number. The number is still 10. There's no letters. There's no letters. There's no, after 9, there's nothing else. Base 12 is even too far out for me. I don't even know what base 12 is. Like, I was doing research. Somebody was like, oh, is this base 5? I'm like, no. What, you know what base 5 means? Oh, hold on. Hold, please. Let me verify. I'm like, today is the worst day. I'm ranting so much. I'm so sorry. But like base 5, you know what base 5 means? The numbers only go up to 5. I think it goes from 0 to 5. Something like that. And it's just like, well, then this cannot be base 5. This is base 10. This is base 10 and only 10 because it goes from 0 to 9. I just find it funny. Why? Because I find it funny because they use big words. Base 5, base 10, base 16. And then I have to think about it. It's like, that doesn't make sense to me. And then I have to go research. Well, why doesn't it make sense? Because base 16 is our hexadecimal when we talk about colors. I don't know what base 12 is. I don't know when we use base 12. Somebody was talking to me about binary. It's like, I don't know binary either. I don't know why. I mean, I don't know binary. I know of it, but I don't know how to use it. Base 5 would be, yeah, right, Jacob? Base 5 is 0 to 4. This abacus is not base 5. This abacus is base 10. Right? Base 12 would make data explode. I guess. I don't know. I don't know what base 12 is. But like this, like the colors of of web designing, this is base 16. Wouldn't change anything in real math. Yeah, that's true too. That's true too. But I think I get a little annoyed because people are trying to be smart, and they're trying to, I don't know, maybe they're trying to prove me that I'm not smart. I know I'm not smart. I know the abacus. That's all I know. To talk to me about base 10, I'm fine. Talking to me about base 16, I'm like, you know what? I know how to change the color of my letters for, my font colors, but that's as far as it goes. I don't care to read how to make a peach color with my hexadecimal. Anyways, so that was a little bit of another rant. Let's talk about abacus. What questions do we have? Trying to watch TV on your remote. Trying to watch TV? Really? I meant Data from Next Generation. Oh, yeah. I was thinking about that. I was like, yeah, Data. Yeah. I used to have the strangest crush on Data. Brent Spinner is his name. I don't know. I think it was because he was such an intriguing character. I don't know how he is. I don't know how he is as a person, but I remember like going through it. But, anyways, that is not abacus. Who did? Oh, okay, good. The formulas in your hands are only the ones we need. You know what? Yes. So if you think about it, we have a set. So we have the plus 5 formula. Let me move that out. Plus 5 formula. and then the plus 10 formula. That's all we need. And then I know some other people are be like, well, how do you do grouping and regrouping? If you really think about it, grouping and regrouping is only adding a 10. If you really think about it, right? If you really think about it, we're only adding a 10 or we take away a 10. That is all that we're doing. That is the simplest like thing to do. We can talk about it. We can do it, right? So, let me see if I can find my, right? So, like, we could take any question, and I know there was this, but the one thing is when we do grouping and regrouping, not the problem of grouping and regrouping. The problem is when it becomes to be 2-step or 3-step equations. Now, what does that mean? It's when you take these and you mesh them together. So if you notice there's a minus 2 here, there's a minus 2 over here. This minus 2 can be sometimes this way. So we combine the 2. If I don't have enough beads to take away the 2, then I have to minus the 5. Does that make sense? So it's like knitting. You know how knitting, we have one yarn, and depending on how you tie the knot, depending on how you knot, you can make anything. You can make a scarf, you can make a mittens, you can make socks. So I was thinking about it. It's like, yeah, making a scarf is like using these. So we have plus the 6 minus the 4. If you notice, minus the 4 is also here. Oh, not here. Here. So minus the 4 can be minus the 5 plus the 6. Let's talk about it. Let's talk about a question. I mean, it's great to see it. Let me see if I can do this. Oh, that's better. All right. So here is a question. One question. We're going to do something first. We'll do something first with this, just doing a carryover, borrowing. So we do 15 minus 7. Well, what's minus 7? Minus 7 is, when we make a 10, it's minus the 10 plus the 3. So all we got to do is take away the 10 plus the 3. So when I have my abacus, that's all we're doing. We have 15, take away the 10, and then add the 3. And that's all we're doing. So my answer is 8. Now here's a 2-step. The 2-step is when we do 14, take away 8. Minus the 8 is equal to minus the 10 plus the 2. You'll see when I have 14, I want to take away the 10 because we're going to take away the 8. So what I'm going to do, I'm going to take away the 10 and I need to plus the 2. This is where the 2-step equation happens. Why? Because I have no more beads to add the 2. What's another way? So now what we're doing is we're providing critical thinking. We're building critical thought in our questions. How do you plus a 2? Plus the 2 is equal to plus the 5 minus 3. So what are we going to do? Plus the 5 minus 3. See, these are all the same. These are the same formulas. It just depends on how you mesh them together. Yes, exactly. Plus the 5 minus the 3. Exactly. JB, were you able to follow that? Are the formulas in your hand the only ones we need? Yes. So were you able to follow the 14 take away 8? And then there's the others, right? Right? It makes sense. And so when you get used to it, you can start seeing the abacus in your brain. Like sometimes I can see if the question is a 2-step question or more, 2-step or not. So here's a question, right? Here's another question. And this is super simple. Let's do 4,000 minus 5. This is easy. This is easy. Hey, Suri. So we do 4,000. Let's do 4,000. 1, 2, 3, 4. 4,000 minus 5. All we got to do is minus the 5. How do we take away the 5? Minus the 10 plus the 5. So here, I'm going to minus the 10. I'm sorry, I can't do that. Minus the 10. I'm going to minus the 10 plus the 5. Well, before I forget, I'm going to add the 5. So I'm going to add the 5. I want to minus the 10. What's another way to minus the 10? Do we know how to minus the 10? Minusing the 10 is just this. Minus the 10 is We don't have any more beads. Can we minus the 1? No, we can't minus the 1 because we don't have any 5. So what are we going to do? We're going to minus the 10 means we're going to minus the 10 again and then plus the 9. So we're going to minus the 10 plus the 9. I'm going to add the 9 here so I don't forget. I'm going to take away the 10. Again, minus the 10. Minus the 10 is, can't do it. So what do? I do it again. Minus the 10 plus the 9. I add the 9 because I don't want to forget it. And I want to take away the 10. Now I'm here. Can I take away the 10? Yes. So now I am done. My answer is now 300,995. But again, it's all the same formulas. It just depends on how you do it. It just depends on how they all get connected. Did that make sense? It just depends on how they get connected. And they all fit together somehow. You just got to figure out how it connects. It's different like a puzzle. It's more like Legos. You get one block and you can make anything with it. You can make a house, you can make a car. It makes so much sense. It's scary, right? It blows my mind. But like this, somebody would be like, "You know what? You made it really complicated." I'm like, "You know what? I just made it scalable." I just took what I knew from our adding and subtracting from our, right? This is fundamental things. I just took this and I just expanded this. That's it. Yeah, right? And it's another rant. It makes me mad. It makes me mad when people are not open to understanding this part and they're like, "You know what? That just made it too complicated." And it's like, "Okay, that's fine. That's fine. I'm not for everybody. Abacus is not for everybody. I understand." But then there's strategies behind it, right? I don't know what strategies this would be. Public schools don't want critical thinkers. Right. Exactly, which is really strange. But you know what? Because of the age of the internet, we are farther along than we ever was when I was a kid. And I am so jealous of the kids today. You guys can do so much. Hey Barbara, welcome back. Oh, welcome back. Thank you so much for the popular. I just started going on rants and I just really yeah. But no, but because of the internet, when I was a kid, we had encyclopedias and we were told to, get a job and then stay in the job forever. But then I got a job. I'm a computer programmer. And then I started jumping around because you need to keep up with your skills. And then my dad's like, why are you, you just got to stay in one place. I'm like, I'm not going to make any money if I just stay in one place. You got to keep moving. But now, you guys, the kids now, oh, thank you for the heart. But now you guys can actually don't even need a job because there's the internet. There's like so much out there for you guys. And it just amazes me if you can just do something. It's fantastic. Like I never have I thought that people would be enjoying my worksheets. Why? Because I only had my brother and my dad to say, "You know what? Your worksheets are really complicated. Information superhighway." Yeah, exactly, right? Like it's amazing. And I wish I started earlier, but I I am of Gen X. We were never I am not entrepreneurial. I mean, I'm trying to right now, but it's just amazing. I just find it so amazing and I appreciate everybody that comes to my live and I can just rant and talk about it and say this is the greatest thing next to sliced bread. And I find it very fascinating. And I feel confident that, as the people go through, I'm hoping that when you guys have children, you will teach your children, right? And I'm hoping to make workbooks and worksheets to be able to support that. And I'm sure you guys will make the same thing. You guys will make your worksheets and all this and that because that's what we do is we produce things, but we just don't. Anyways, so that's another rant. I do a lot of rant today. Oh, thank you so much for the hand heart bells. Okay. So what's another question? Do we want to go further into adding and subtracting? But that's the thing. The formula cutouts are in your book. No, the formula cutouts is I sell it on my website, or or I give it to my classes. I'm selling it for $3, but there's more pages. And I have a little video that goes with it. me see. Let me show you. Let me show you the little formulas. So, sorry, I'm trying to find my papers so I can show you what's in it. There's a set, and it depends on. I can't believe how disorganized I am. But yeah, there's a set of 5 or 6 pages. Let me see if I can find. I'm sorry, I'm trying to find my pages so I can show you what's in it. So it's a PDF, and and it's different ways. Okay, here. I just feel like, is it here? Oh, I don't know if this is it. Sorry, I'm trying to. Oh, here it is. Here it is. So, it's this. So I have it where it's 5. I think it's 5 pages, and the way I have it is, and I have a little video to have instructions, and you cut it out. There's your tens, right, and then your 5s, and then I cut out the 5 already. That was part of the video. And then there's a single-sided. So if your printer is not double-sided, you can do single-sided, and you just kind of you can glue it together, right? And it should fit nicely like this. It should fit nicely like this. If you have a printer, it will be double-sided. You can use the other one that's double-sided. So I try to make it double-sided, and that's why I did this. And then what I did here is laminate it. And yeah, so this is fun, especially with an abacus in your hand, in my hand. Yeah, it is fun when you get the abacus, because then you can start moving it and stuff. But I would recommend to laminate this if you could. This is I just taped it, but that's what I did, and so that's why it's a little shiny. Sometimes it's the light that comes down, it reflects the light. But what I did is I just used shipping tape. But you could laminate it. I don't know if you're close to a laminator or whatever. But yeah. And then, but I do sell, it's like $3. And you get 5 pages, I believe. This one, the reason why I did it this way was to test. So the idea was to try to test you. So like if I had this and you wanted to, this, and I wanted to know what +1 is, then you can flip it out like this, and it goes like that. So this is like kind of like testing. And so yeah, I have a little thing. Yeah, not a problem. I you know where it came from, right? It came from this. And somebody said, "This is really cool." And I'm like, "Really?" This thing that I made was actually for my kids, and this is about 10 years old. And this is made out of leftover packaging, because I can't throw away anything. So what I did is I used like packaging, and I just cut it. You could do it on your own. It's up to you. But yeah, I thought that this was pretty. So, hey Gary, pronounced Dave. That's funny. Yeah. So this itself is 10 years old. Yeah, my kids thought that they were cheating, but they're not cheating. I just let them. Yeah. Yeah, so then, but if you wanted to print it out, it's available. I think I'm selling it for $3. But it's pretty versatile. And then I was getting in the process of going into creating my book for adults, because apparently that was a thing too. I didn't think that was a thing. I honestly didn't think that was a thing. But my plan is to push out a book before the end of the month. But we'll see. We'll see if I can get that out. Yeah. But yeah, it was just kind of funny. And then, yeah. But, it's interesting because, the kids are older, so they don't need me as much. So I have some time to be creative. Yeah. So, no, thank you. Thank you, TNG and JB. Hey, JB, I don't know if you follow a comedian. His name is Henry Cho. He has a friend named JB. It's kind of funny. I thought it was funny. But yeah. All right. Is there any questions? Any questions? Any questions about Abacus? Any questions about Abacus? We can continue on with adding and subtracting. Uh-oh. Oh no, violation warning. Your live is flagged for hate speech or hateful behaviors. Repeated violation could result into your live being discontinued. What was my hate speech? Because I don't like math? No, I like math. I guess I didn't like new math? But how? Yeah, I don't know. JB? Maybe it's JB? But it's a he's a comedian. His name is Henry Cho. Love him. Love him. Anyways, it is what it is. But it's okay. I think it's getting kind of late, and it's okay. It's getting late. Agents are listening. Yeah, right. Agents are listening. Agents are listening like The Matrix. Oh, yeah. Oh, my God. That was a great movie. I watched it when it first came out. That's how old I am. When it first came out, I was watching The Matrix. I love The Matrix. I love The Matrix. The husband slept through it 5 times. Teacher people how to think, and they don't like it. Yeah. All right. So, is there any other questions? Or we can continue on with more Abacus, or any specific questions you have teaching other people. Yeah, and how to critically think. Yeah, that was the one thing. Any specific questions? Any dying questions that you wanted to ask about Abacus? We didn't do too much today. I did a lot of ranting. I did a lot of ranting about what is it? New math and so forth. But we could talk about anything. We could talk about anything Abacus related. Come on, questions? No questions? Ranting is healthy. Well, yeah. Oh my God, it boils me. But I have to remember. I mean, this is why I'm here. I'm trying to bridge the gap. I'm trying to bridge the gap for math, and to make it more math fluency and flexibility and all this and that. Thank you so much for the follow. La bichota chapina. I don't know if I said that right. I hope I said that right. Okay. So, Barbara, I don't know if Barbara's still here. Did you have any questions? Anything about Abacus? Anything that you guys want to talk about about the Abacus? We could continue on. So we could talk about the double two-step equations. So the first two-step equation, the other one would be, it depends on where it is. So, oh, fantastic. Fantastic. Here's another two-step. How is this two-step? Because now we're going to talk about the other 5. So if we did, we'll do plus 5, because plus 5 is easy. But 49, when we do 49, we had the 4 and we had the 9. We're going to do the plus 5. Again, what do we do with the plus 5? Plus 5 is equal to plus the 10 minus the 5. Now, if you notice, I want to plus the 10. This is where we are thinking again. This is critical thinking. If we cannot add the 5, what can we do? Well, I'm sorry, plus the 10. Because right here, I want to plus the 10 and add and minus the 5. I want to plus the 10. How do we plus the 10? Remember that plus the 10 is very similar to plus 1. So only plus 10 means to go to the next column over. I'm already at the next column. Let's strip it down to 1. So what do we do? Plus 1 is equal to plus the 5 minus 4. All I got to do is plus the 5 minus the 4. And then minus the 5 again. And that's it. So my answer is 54. But this is where number flexibility comes into play. Why? Because it's this number, the 10, that touches the 4. So now we know, and this is the thing, right? Now we know that we have to figure out how, it's not jerry-rigging it. We're not jerry-rigging it. We're trying to fit the pieces. We're trying to fit the pieces that we have. So it's like Tetris. That's what it is. It's like Tetris. We have certain numbers, certain formulas, and how do they all fit in? So because we were adding the 10 here, we know we're going to be able to do that. That's what it is. It's like Tetris. How do you fit what we know into the block to make a line? Ah, that's beautiful. That's beautiful. Thank you so much for the hearts and the diamonds and the likes. Io's been very quiet. Io, you all right? I don't know what this emoji is. I don't know what it looks like. It looks like it's an ape. So that's the two-step equations, which is interesting, right? And I think we underestimate the power of addition and subtraction. So again, it's the same thing. We know how to add. It's the same process as minus. So if we had the question 53 take away 5, same thing. I have 53, so I'm going to add 53. Add 50, I add 3. Now I need to minus the 5. We know how to minus the 5 because we know how to plus the 5. If we know how to minus the 5, if we know how to add the 5, all we got to do is reverse all we have to do is reverse the operations. So we're going to minus the 5 is equal to minus the 10 plus the 5. So what are we going to do? We're going to minus the 10 plus the 5. There we go. Minus the 10 plus the 5. We cannot minus the 10 here. Why? Because there's no more beads to take away the 10. Notice minus the 10 just means we're going to go one column over. So we're going to change this to be minus 1. Minus 1 is minus the 5 plus the 4. So we're going to minus the 5 plus the 4. And then plus the 5. So my answer is 48. And that's it. Thank you so much for the heart me, Beal. Okay. Whew. All right. It is getting late. It is 11:40 for me. I'm not sure where everybody else is. If you're on the East Coast, it's very late for you guys. I am going to sign off. If there's no other questions, I do appreciate everybody listening to me rant. I have to be careful to get this I have to be careful. This is getting too intuitive. Yeah. I think the one thing is to make sure you use the beads and move the beads as they go. Because we can think about it in our heads and we just know it. But if you really want to use the abacus, I would try to use the abacus as much as possible, until it gets to be more regular. Hello, David. Yeah, because sometimes, yes, yeah, I understand, and it can be, yeah, if that makes any sense. So, if there's no other questions, let me know. I'll see everybody else on the next live. I thank you guys for joining me and my little rant and my raving about new math. Whew, new math. That and was it hexadecimals? All right. No, thank you, Beals. Thank you, Beal. Okay. If there's no other questions, I will see everybody in my next live. Everybody have a good night and have a good day. Have a good night. Have a good day. Thank you. Thank you, JB. Thank you. Okay. Have a good night, everybody. Bye.